Welcome. You are welcome to MTH 102 General Mathematics 2 Study Section 9. In this study section, I shall be taking you through integration. However, to aid your understanding, the study session has been divided into two parts. For the first part, we are going to be considering the first three learning outcomes. What is integration? Integration is the mathematical method of finding integral for a function at any point in a given graph. For instance, if you are asked to find an integral function with respect to x, it means finding the area to the x-axis from the curve. This study section will consider the following learning outcomes, of which you are expected to be able to understand them. 1. To be able to explain the basic rules of integration. 2. To solve problems using integration. 3. To apply properties of definite integrals in solving problems. 4. To be able to solve mathematical problems using techniques of integration. 5. To apply integrations in solving problems that involve areas, volumes, and moment of inertia. For the sake of emphasis, like I earlier said, the last two learning outcomes shall be covered in the second part of the study section. Basic rules of integration. There are four major basic rules that are being used in integration, and these are the power rule, the multiplication by constant rule, sum rule, as well as the difference rule. We shall be taking these rules one after the other. Power rule. The first of the rules, which is the power rule, is what we have on the board. And don't forget that in solving any integration problem, there is a general rule to that effect, just like we have on the board. Take for instance, you have an integral x to the power n dx. In this case, this n is the power, while x is the function. So if you are to integrate this, what you are going to have is that you have x, you had 1 to the power, all over the sum total of the power, which is n plus 1, plus constant c. Take for instance, if you are to solve this integral function x raised to the power 4, just like we have on the board, what you are going to do is that you have integral of x raised to the power 4, then this will definitely give you, in this case, you know that n, in this case, is the 4 that we have there. And we are going to have x, just like I have for the former one, you had 1 to the power, that is 4 plus 1, all over everything that you have for the power, which is equals to x. 4 plus 1 will give you 5, all over 5 plus c. The second rule that we are going to be considering is the multiplication by constant rule. This is the function of the form integral of c fx dx. And when this is being integrated, this will definitely give us this function. It will give us this. However, it doesn't just happen like that. But what there is a first, that the second rule is the multiplication by constant rule. Take for instance, we have a function integral of c f x dx, when it is being integrated, what we are going to have is, first of all, bring the constant out, that is c integral of f(x) dx. Now let's go through this example on the board to have a better understanding of what I just explained. Take for instance, you are given this type of function, integral of 12x squared dx. What you are expected to do here is, first of all, bring out the constant 12. Then you now integrate using the power rule. This is what I'm saying. You have 12 integral of x squared dx, and coming from the question that is being given. Now what you are going to do here is that you now integrate x squared, that is x 2 plus 1 all over 2 plus 1 plus constant c. Hence what you are going to have is, you have 12 2 plus 1, that is x raised to power 3 all over 3 plus constant. But you can cut this 3 by this 12, which will give you 4. Then you have 4x cubed plus c to be the integral, the integral form of to be the integration, to be the solution to the given integral. Now the next rule we are going to be considering are the sum and the difference rule. The sum rule of an integration states that the integral of the sum of two functions is equal to their sum of integral. Take for instance, what we have on the board, integral of f, that is open bracket f plus g dx, like we have here. Integral of open bracket f plus g dx, like we have here. Then this can further be broken down into two, that is integral of f dx plus integral of g dx. Similarly, the same rule goes for the difference rule, only that the sign will change. Definite integration. The first theorem of calculus allows definite integrals to be computed as indefinite integrals. The first theorem states that if f is an indefinite integral for a function f(x), then you can have the expression like this that we have on the board. That is integral of a b f(x) dx, where a and b are the lower and upper boundaries. Then you are going to have the solution like what we have on the board, that is subtracting the function of the upper boundary and the lower boundary. That is, you subtract the lower boundary out of the upper boundary, FB. Now let's consider this given example. Integral of that is, you are to integrate x raised to power 5 dx from 0 to 1. Then you will have this as your answer. Now what you are going to first of all do, 5 dx. What we are going to do is to integrate x, that is 5 plus 1 all over 5 plus 1, then 0 to 1 plus c. Then from here our integral, our solution shall be x raised to power 6 all over 6 plus c. then you input the two boundaries. Then what we are going to do is that in this case our lower boundary is 0 while our upper boundary is 1. So you are going to start from the upper boundary by substituting the upper boundary, which is 1, into the solution. That is, we have 1 raised to power 6 all over 6. Then we are going to substitute the upper boundary. Then we subtract minus the lower boundary. Just like what you have on the board. X, then you put 1, that's 1 raised to power 6. Then over 6 minus 0 raised to power 6 over 6. This one will definitely be 0. Then we are going to be left with 1 over 6. To further have a better understanding, let's go through this function again. Now, if you are asked to evaluate 3x squared dx from 1 to 5, you first of all consider the multiplication by constant rule, that is bringing out the constant outside. Then we have something like this: 3 integral of 1, 5, x squared dx. Then we are going to integrate x squared, just like what we are about doing. Then we have 3 integral of x squared will definitely give us x 2 plus 1 all over 2 plus 1. Then plus constant. However, you will not forget putting the boundaries. That is 1 and 5, the lower and the upper boundary. Then from there we have 3 into bracket x cubed, that is x raised to power 3 all over 3. Our boundaries 5, then plus constant c. Then the next step for us to take now is to substitute the boundaries, that is from the upper one to the lower one. Then what we are going to do now is that we have, don't forget from this expression, 3 can cancel 3, then we are going to be left with x cubed, that is x cubed 1, 5. Then from here we have 5 raised to power 3 minus 1 raised to power 3. Then 5 raised to power 3 is 125 minus 1 raised to power 3 is 1. Then we are 125 minus 1, then we are going to be left with 124. Now, integration as the area under a curve. Normally, every definite integral has a definite value, and the value can be interpreted to be a particular area under a given curve. Take for instance, if you are to integrate the function fx, which is equal to minus x squared plus 4, using the given graph, that is the graph below. Now, if you look at this graph critically, what you are going to discover is that the roots of this equation are minus 2 and 2, that is where the curve cuts the x-axis. So with this, what we are going to have is that our lower boundary here, lower boundary will be minus 2, while our upper boundary will be 2. Then the integral form that we are given then will now be written, can now be written as minus 2, that is the lower boundary, 2 minus x squared plus 4. Then let's solve it to better have a clear understanding. The integral has been written in this form, that is, we have imputed the boundaries, that is the lower and the upper boundaries. The lower boundary in this case is minus 2, while the upper boundary is 2, that is fx dx. Then we subtract the lower boundary from the upper boundary. So what we have on the board now is that we can integrate this, that is, the integral form of this now will be minus x raised power 3 all over 3 plus 4x plus c. That was how we got this. That was how we got this. Then from here, just like I told you earlier, I said you are going to first of all substitute the upper boundary into the given equation now. Then that is what we actually did here. We first of all input 2 to the equation before we now subtract it from the other one. Now what we did was that we put 2 in this, that is we have 1 over 3, our x here, then you substitute for 2, this is our 3, then 4, our x is 2, we put 2. Then similarly for minus 2, instead of 2 now we substitute it for minus 2, that is minus 2, minus 2. Now what we did there was that we obtained the solution to this, that is 2 raised to power 3, that is 8. So 8 multiplied by 1 multiplied by minus 1, that is minus 8, then over 3, then plus 4 times 2, that is 8. Then for the second aspect of it, if you obtain minus 2 raised to power 3, we have minus 8. Minus times minus, that is plus, and that was how we got 8 over 3. Then minus 8, that is 4 times minus 2, that is minus 8. Now, we simplify this, then I obtained 16 over 3. Then for the sake of this one too, we had minus 16 over 3. Now, we now expand this bracket. Minus times minus will always give you positive, that is plus. Then we have 16 over 3 plus 16 over 3. Then eventually we have the final answer to be 32 over 3. With this, we have come to the end of the first part of the study section 9. I do enjoy you to study the second part of study section 9 to have a better understanding of all the plans. Thank you for listening.